Welcome to the Trident Analyst tutorial on road cross-sections and vertical clearances. Use the road cross-section module to automatically generate cross-sections of road surfaces and compute vertical clearance measurements and generate vectors over each of the cross-section points. Before you can begin generating cross-sections and vertical clearance information, you must first create a point layer to save your cross-section points to. The following fields are required for this analysis and must be added to your layer. These fields are automatically populated by this module: cross-section ID, ID point name, lane width, chain, and clearance. Create a second layer with polyline geometry to be populated with the vertical clearance vector results. The clearance field is required for this analysis and must be added to this layer. It will be automatically populated by this module. After the layers are created and loaded onto your GIS panel, you can begin generating the cross-sections and vertical clearances. To begin, launch the Road Cross-Section module. From the Tools menu, select Extension Module Manager, and then click the Load checkbox for Road Cross-Section and click OK. Click the Add button and select the laser file you want to work with. Laser files are usually saved in your project's Run Data folder. You can add multiple laser files, but for the purpose of this tutorial, I will add just one. Notice that the laser file is now listed in the box. Next, set your parameters. The frequency is the distance in meters between each cross-section point along the surveyed road. I will leave it at the default of 3 meters. The thickness enhances accuracy by using laser points that surround the cross-section point. So for this example, the software will use laser points that are within 3 centimeters of the cross-section point to refine the z-coordinate of the cross-section point. Next, set the number of slopes to be computed for one lane. So for this example, the software will compute 11 slopes, generating 12 points so that I can have a dense profile line. If you wish to only compute a single cross slope for one lane of road, a value of 1 would be entered here. Number of profile points is not applicable to vertical clearance measures. If you wish to only focus on a specific area, such as the vertical clearances of a bridge, then check Use GPS time limits to limit the generation to only the portion of the road where your area of interest begins and ends. You can get this info from the status bar at the bottom of your screen. For this example, I will scroll to the beginning of the bridge, enter in the start GPS time, then scroll to the end and enter the end GPS time. If instead you wish to analyze the entire sequence, do not check the time limits option. Next, set the generation method. You can set fixed lateral distances for the profile generation or limit it to between 2 pavement lines. For this example, I will set the fixed lateral distances. Minimum is -5 meters and maximum is 5 meters. To limit the analysis between predefined vectors such as pavement markings or edge of pavement, use the Input Pavement Layer option and choose the appropriate vector later from the drop-down menu. Next, set your output settings. Select the Define Polyline layer to save your vertical clearance results to. Then select the Points layer to save your cross-section points to. Then click Process to begin processing the data. When finished, you can view the results in the 3D map. For this example, my profiles are 3 meters apart and each contain 12 points. You can recenter the map on a point, select the 3D perspective view to get a better visual of the profile points and bridge clearance. To view information about a cross-section point, use the Identity tool and click on the cross-section point that you want more information about. The layer form appears showing values for all fields that you defined when you created the point layer. To see the vertical clearance measurement, click on the clearance line. That is it for this tutorial on generating cross-sections and vertical clearances. Thanks for watching.